Okay, remember when we're dealing with functions and relations, that a function is a relation where every x in the domain is only matched with one y from the range. All right, so for example, if I check the x coordinates, I see the 1 is repeated, so that means this is not a function. If I have a list of some sort, meaning just a literal list like this, or a table of values, or a diagram with arrows, then all I have to do is look at the x values. If I'm looking at a picture instead, like we did in some of the other videos, remember then I do what's called the vertical line test. And if no matter where I draw that vertical line through my graph, it only intersects in one place, then it's a function. So maybe this is the point 0, 3. This is the point 2, 0. And I said, well, I'm going to give this function a name. So this one is a function because it passes the vertical line test. Then if I ask you to find f of 0, that means when x equals 0, what's the y value? When f is equal to 2, what's the y value? Okay, I didn't make a very nice function here, so those wouldn't be very nice values at 1 or -1. But if I have a graph, I go left or right on my graph until I get to that x value. And my answer is whatever the y coordinate is at that point. If I'm given an expression, g of x equals x squared minus 9. My pen won't write 9. There. If you're asked to find g of 2, then I'm going to replace all of the x's with the number 2, do the arithmetic, and see what comes out. Okay, this is my x value that's going in. My answer is the y value that comes out. Okay, and regardless of how you're presented with that function, you should be able to find f of 1 or g of 2. I said 1, but in my picture 2 would be better. F of 2 or g of 3 or p or q of 1 or 5 or 7. Okay. You need to know how to add or subtract or multiply or divide functions. I don't know if I can make this where you can see it all. Okay. And so for the blue f that I drew the picture of, the black g that's at the right, oops. Okay, this would be f of 2 plus g of 2. I plug 2 into here, I plug 2 into here, and then I'm going to add those numbers together. So f of 2 was 0. G of 2 is -5. I'm going to add them together to get -5. No, if this was a minus sign, I would subtract those numbers. If it was multiplication, I would multiply them. If it said divided by, I would divide. I also need to know, oops, I need to write what I mean to write, how to do the composition of functions. The first function on the list is on the outside. The second one is on the inside. So this says I need to start by finding g of 3. If I plug 3 into g, I get 9 minus 9, which is 0. And this says now the 0 is going to go into f. And so I come back here to my picture. Here's x equals 0. I go up until I find the y value. So f of 0 is equal to 3. Know how to move functions up and down. Know how to move them left and right. I think that was either 2.6 or 2.7. Know about symmetry of functions. Okay, what moves them up and down, left and right, what stretches and shrinks them, what reflects them across one of the axes. Okay, know how to check for symmetry or what it means, what they would look like if they were symmetric with respect to x or to y or to the origin. This blue function here is symmetric with respect to the y-axis, because if I fold my paper on the y-axis, the left and the right sides would match up. Okay, this one also symmetric with respect to the y-axis, because if I replace x with negative x, remember it's always the opposite letter of the axis we're testing symmetry on, I get the same thing. If I replace x with negative x, I get the same thing as I started with. So that would tell me I have y-axis symmetry. Know how to deal with functions, know how to give domain and range for a function. And we've done that with the circles, we did that with the parabolas. Domain and range on a line is almost always all real numbers for both of them. Okay, so give me a shout if you need help with any of those pieces.